Welcome to The Explainer. I'm so glad you're here because honestly, we're tackling one of the most wild, rapidly evolving, and frankly misunderstood topics out there right now. Just imagine a world where a machine can write a killer story, diagnose a super rare disease, navigate chaotic city traffic, or just whip up a stunning piece of original art in a matter of seconds. Well, guess what? We're not talking about 50 years from now. We're not even talking about 10 years. This is happening right now. AI isn't just some sci-fi pipe dream anymore. It's our present reality, and it's literally reshaping how we solve problems. So in today's Explainer, we're going to break down exactly what AI is, how it actually ticks, and where it's taking all of us. Let's get into it.
All right, here's our roadmap for today. We'll start by looking at AI in your everyday world, dive into how we actually got here, and explore exactly how these machines learn. After that, we'll break down the three main types of AI, the massive generative AI revolution happening right now, and finally, weigh the real opportunities and challenges ahead of us.
So, Part 1. AI in your world, the invisible assistant.
You know, it's so easy to think of AI as this distant, high-tech lab experiment run by people in white coats. But the reality? Millions of us use it every single day without even blinking. Honestly, you probably interacted with it this very morning. When your phone magically unlocks with Face ID, yeah, that's AI mapping the complex geometry of your face. When Netflix somehow knows exactly what kind of thriller you're in the mood for, or when Google Maps reroutes you around a massive traffic jam in real time, that's AI quietly doing its thing in the background. Even when YouTube queues up your next video or a search engine finishes your sentence before you're even done typing, you are interacting with artificial intelligence. These tools are so baked into our daily routines that they just feel like normal software, but the engine running under the hood, it's a completely different beast.
And that brings us to the fundamental difference between the tech of the past and the tech of today. Traditional software, it's kind of like a strict recipe. It follows a fixed, rigid list of instructions. You know, if X happens, do Y. But artificial intelligence is a whole different ballgame. Instead of relying on rigid rules, it analyzes massive piles of data, spots hidden patterns, and actually adapts based on its experience. So the more high-quality data you feed it, the smarter and more accurate it gets. It doesn't just blindly execute commands, it actually learns.
Which leads us to Part 2. How did we get here? The evolution of AI.
Because, look, while AI feels like this brand new thing that just dropped out of the sky yesterday, its roots actually go way back, over 80 years. It all kicked off in 1950 with a really profound question from the brilliant British mathematician Alan Turing. He simply asked, can machines think? Turing proposed an imitation game, which we now call the Turing test, just to see if a machine could actually fool a human in a conversation. And that single brilliant thought experiment, it sparked a completely new scientific field.
And wow, since then, the milestones have just snowballed. Just 6 years after Turing's paper, in 1956, the term artificial intelligence was officially coined at the Dartmouth Conference. For a long time, researchers were just building expert systems, slowly chipping away at the math. But then, the breakthrough started making front-page news. In 1997, IBM's Deep Blue did the impossible and beat world chess champion Garry Kasparov. Fast forward to 2011, and IBM's Watson is out there dominating Jeopardy, proving machines could finally grasp all the weird nuances of human language. Then in 2016, AlphaGo beat a human world champion at Go, which is a mind-bogglingly complex board game, even playing moves no human had ever thought of. And that momentum brings us right to today, the era of generative AI. We've literally gone from machines that play board games to machines that write essays and generate art.
All right, moving on to Part 3. How does AI actually learn? Teaching machines. So, how exactly do they do it? Well, the most important thing to wrap your head around is that AI does not think like a human. Instead, it churns through colossal amounts of data to find patterns. Think about how you teach a toddler to recognize a cat. You wouldn't sit them down and hand them a list of strict rules, right? Like, okay, kid, a cat has 2 pointy ears, whiskers, and a tail. If you did that, they'd probably end up calling a mouse or a small dog a cat. Instead, what do? You just show them pictures. You point out a cat in a picture book, a cat walking down the street, maybe a cartoon cat on TV. And after seeing enough examples, the kid just naturally gets it. They recognize the catness. Believe it or not, AI learns the exact same way. You don't program explicit rules. You just feed it thousands or even millions of examples until the pattern clicks.
Today, we achieve that kind of pattern recognition through a broader approach known as machine learning. But the real magic happening right now, the stuff making all the headlines, is a specific subset called deep learning. Deep learning relies on artificial neural networks, which are actually mathematically inspired by the physical structure of our own human brains. These deep, complex layers of artificial neurons are what finally unlocked AI's ability to reliably recognize faces, translate speech in real time, and generate all that crazy creative content we're seeing today.
And all of this comes together in a very specific three-step life cycle for basically any AI system. Step 1 is data collection. This is gathering up the massive mountains of text, images, medical records, or audio that the system is going to learn from. Step 2 is training. This is the heavy lifting where supercomputers adjust billions of mathematical parameters over and over and over until the AI's pattern recognition gets incredibly sharp. And finally, step 3, inference. This is when the fully trained AI is let loose in the real world, taking all that stored knowledge and applying it to brand new situations it's never encountered before, like your phone recognizing your face in a dark room from a weird angle.
That brings us to part 4, the 3 types of AI, categorizing intelligence.
Now, it is absolutely crucial to understand that not all AI is created equal. Scientists basically break it down into 3 distinct tiers: narrow AI, artificial general intelligence, and artificial superintelligence. We're going to dive into the first 2 in just a second, but let's take a quick detour on that third one. Artificial superintelligence is completely theoretical right now. We're talking about a system that blows human intelligence out of the water in literally every domain: science, art, strategy, you name it. And while that makes for some awesome sci-fi blockbusters, superintelligence is highly speculative. And honestly, researchers are still debating what that would even look like in reality. So let's look at the sharp contrast between the AI we actually have right now and the ultimate goal researchers are chasing. Narrow AI is our current reality. Every single AI tool you use today, that's narrow AI. It is amazing at one specific task, like translating French to English or spotting a tumor on an X-ray, but it literally can't do anything else outside of its designated lane. Then we have artificial general intelligence, or AGI. This is the holy grail of the field. An AGI would be able to understand, learn, and solve problems across vastly different subjects, exactly like a human being can. We are definitely not there yet, and there's a ton of fierce debate about when we'll get there, but make no mistake, that is the ultimate finish line for the industry.
Okay, Section 5, the generative AI revolution, creating new content.
This is where things get wild, because the technology has evolved from just analyzing old data to actively creating entirely new things. The absolute powerhouse engine behind this current creative explosion, they're called large language models, or LLMs. You've definitely heard of tools powered by them. These immense systems are trained on an unimaginable scale, literally trillions of words scraped from across the internet, so they can deeply grasp the patterns, the grammar, and the facts hidden inside human language. They're the reason AI can suddenly write functioning computer code from scratch, design a corporate logo, or even compose a full symphony.
But here is the crazy secret behind it all. The core mechanic of these massive LLMs isn't that they're just memorizing answers in some giant database. Not at all. What they're actually doing is simply predicting the most likely next word based on the context of whatever you asked it. It's essentially the world's most advanced, beefed-up version of autocomplete. But the thing is, when you take that relatively simple idea and scale it up with massive computing power and absolute mountains of training data, just predicting the next word somehow transforms into this remarkably capable, creative assistant that feels almost human. It's wild.
Finally, part 6, opportunities and challenges, weighing the impact. Because this powerful technology is already completely reshaping every major industry out there. In healthcare, it's catching diseases way earlier than human doctors can, and even tailoring treatments to your specific genetics. In education, we're seeing these custom AI tutors that actually adapt to a student's unique learning pace. Look at agriculture. AI-powered drones are flying over fields, monitoring crop health, predicting yields, and seriously cutting down on food waste. And in the hard sciences, AI is basically acting as a tireless research assistant, radically speeding up discoveries in physics, chemistry, and biology. I mean, it is truly everywhere. But as with any massive leap forward, we have to look at the full picture objectively. We need to weigh these incredible benefits against some very real critical challenges. Yes, AI automates the dull, repetitive stuff, skyrockets our productivity, and unlocks totally new forms of creativity. But on the flip side, because AI learns from historical data, it can very easily inherit human biases built into that data. Plus, we are actively having to figure out how to deal with incredibly convincing misinformation, massive shifts in the job market, and the sheer amount of energy these supercomputers gobble up. These aren't just minor speed bumps, they're complex, urgent engineering challenges that demand really thoughtful solutions.
Which leaves us with a pretty profound question to chew on. How do we ensure this massive transformation actually benefits everyone?
Because artificial intelligence isn't science fiction anymore, it is arguably the defining technology of our generation. The question is no longer if AI will change the world, because, well, it already is. The real task in front of us is responsible governance and smart decision-making. We have to make sure that as this incredible tool expands what we're capable of, it does so in a way that elevates all of humanity. So think about how you're using AI today and how you want it to shape your world tomorrow. Thank you so much for joining me for this explainer, and hey, keep exploring.